Welcome back. In this video, we'll look at on depthwise conv2d, and for this, we'll need input and the filter. So let's look at the dimensions of those. Input is going to be the batch, that is the number for the batch, and then we have the height, width, and then in channels. Likewise, we would need the filter dimensions. So for filter dimensions, if we go to the docs, here we should see the dimensions for the filter. That's the filter height, filter width, and then we have the channel multiplier. That's the dimensions for the filter. Now we'll create an example. So x is equal to tf.constant, and let's say we are creating an array, and here we'll use the same dimensions that are already here in this example, 1 comma 3 by 2 by 1. So for that we'll need three sort of rows. So I'm going to use 1 comma 2, 1 comma 2, that's the first row. Then we have 3 comma 4, that's the second row. Then we have uh, 5 comma 6, that's the third one. So if we look at the shape of this, print uh, print x dot shape, we should see that the shape is 3 by 2. That's what we have. Now we need to add the batch dimensions. So put square brackets out there. Now we have 1 by 3 by 2. And now the last thing we need to do is add the dimensions on the right side. And for that, we'll add square brackets around these integer values. And that should give us the dimension that we need on the right hand side. So that's it. So that's the array that we have, or tensor that we have, 1 by 3 by 2 by 1. And here we need to specify that the data type is float 32. So we'll do that. And as per the docs, we could also add a decimal value here. So that's the tensor that we have created, which looks good. Next thing we need to do is create a filter. So let's create a filter. F is equal to tf.constant, and again in this case the dimensions that we are going to create the filter is going to be this 2 by 1 by 1 by 2. And for that, let's say we have the values 1 comma 2, and then we have 3 comma 4. And now if we print x, this is f dot shape, then we see that it's going 2 by 2, and the dimensions that we are interested in are these. So we have 2 by 1 by 1 by 2. So what we would need to do is we would have to add dimensions on this side. So that's going to add another dimension. So we have 2 1 2, and then we are going to need another dimension. So I'm going to add a square bracket there and another square bracket here, so that gives us the dimensions that we are looking for. Now before we start working on the code, let's try and do it manually. So for that, here is the tensor that we have: 1 2 3 4 5 6. That's the tensor. And then the filters that we have are as follows. We have one filter, that is this one, 1 3. That's one filter. Remember, this is the height and width. So we have the height and width. So it's a 2 by 1. And next one we have is 2 4. Now we are going to use these two filters on this particular tensor to perform the convolution. And let's select another color. So the very first we'll use the 1 by 3, and so what we would get is 1. And so we are looking at these two, so we are going to look at this one first. So 1 3, and we are going to use this 1 3 right here. So 1 times 1, and this is going 3 times 3, so this is going to be 1, and this is going to be, we are going to plus the 3, and so this comes out to 4. Next, what we are going to do is perform the uh, same calculation on this side. So we are simply going to shift this on this side and again do the calculation. And so this time what we are going to get is, let's say this is going to be 2 4. So 2 times 1, 4 times 3. So that comes out to 2 plus this is 12, and so we get a value of 14. So we have 4 14. And then we are going to move this thing. We are going to move this. We are going to move this down here, and again perform the calculation with the same filter, and values we would now have are these 3 5. So 3 times 1 and 5 times 3, that gives us 3 plus 15, and that gives us 18. Likewise on this side, when we move this particular uh, square green box on the right hand side, that's where we are going to do the multiplication element wise. So we have 4 and 6. So this is going times 1, this is going to times 3. So we have 4 plus this is 18, and so that gives us 18 plus 2 20 plus 2 22, and so that's what we have. This is for the filter, this one. We will repeat the same steps with another filter, and that is going to be the orange filter. And for that, what we'll do is here's what we can do. I'm going to delete this one and delete this and delete this. Now we'll use a different color. Let's use a blue color for this filter, and we are going to use that here. So the first one is 1 3, and we are going to multiply it by 2, and here down here we're going to multiply by 4. So this becomes 2 plus 12, and that's 14. And next we have 2 4, so 2 times 2, 4 times 4, so that gives us 4 plus 16, that is 20. And then we have 3 5, and 3 times 2, 5 times 4, this gives us 6 20. 6 plus 20, that gives us 26. And then we have 4 6, so 4 times 2 and 6 times 4, that gives us 8, and this is 24. And so this comes out to how much? 32, I think. Plus 6, that gives us 30, then remaining 2, so that's 32. And so eventually then those are the values we have: 4 14 18 22 using this filter, 1 3, and then we have 14 20 26 32 using the filter 2 4. Let's now try and calculate this using the code and see what output we get. So what I'll do is I'm going to simply uh, go up here and copy this part and paste it right here. So let's get rid of some of the drawings, and now we can write the result. So this is going to be result, and let's say result is equal to this. And now for the input, we have the input as x, For filter, we have the filter as equal to the f. And then the strides, let's say the strides in this case uh, that have been used. So the strides are 1, 1, 1, 1. So I'm going to use the same strides in here. So we have 1, comma 1, comma 1, comma 1. Padding, let's keep the padding as valid, and the rest of it will leave it as is. And finally, we can print the result dot shape, and we can print the result itself. And now when we run this, let's see what we get. So, oh, so there's a typo, missed the L, and there's a problem. So let's see what it is. Okay, the problem is this, I haven't defined the data type, so we need to convert this to float. So I'm going to copy and paste that text, and might as well put a decimal in front of all these digits. Now run this again, and here is the output that we have. And in the output, we can see that the numbers are, so we have, so the way we want to look at this is as follows. We can take the result, and let's say we look at, we have the batch at 0, and then and here we'll take the all the rows, so height and width, and then we'll look at the index 0 again here. So the output from the very first filter. So we have the values of 10, 14, 18, 22. So probably missed something here. So 14, 18, 22, that's fine. Uh, Something is wrong. Oh, so my mistake. This should have been 9. So we have 9 plus 1. This is 10. Okay. So that works out. Next we have, let's look at second filter. So let me go ahead and erase this tick mark if I can. Okay. The 0 will replace this by 1. Run this again. And we have 14, 20, 26, 32. So we have 14, 20, 26, and 32. So that's the output using the second filter that we have. So this is how we can perform a 2D depthwise conv2d in TensorFlow. I'm sorry about that mistake earlier. I should have seen that. If you have any questions, comments, or suggestions, please do let me know in the comment section below. I hope to see you all in the next video. Thank you.